Okay, for topic two, we're going to continue our chat about polar coordinates. What we left off with was we had two polar coordinates. Let me see, what were they? So we had -3 comma 2 pi over 3. And then we had 3 comma -pi over 3. And what we realized is they represent the same point. They represent the same point or the same location on the rectangle or on the polar coordinate system. Okay. And I ended the video by saying, hey, when we're in the rectangular coordinate system, each ordered pair represents one location in space, and every location in space is represented by just one ordered pair. Okay. However, in the polar coordinate system, each point can be represented infinitely many different ways. Okay. So let's kind of investigate this. So what I want to do is go back up here. Okay. But I want to erase all of the stuff. You can keep yours. This is just more like sort of, so you can kind of see what we're talking about. So let's erase this. Okay. We're going to get rid of this, and I'm just going to look at F and G again. So we're going to look at those points, F and G, one more time. I should have just looped this and erased it, but this, anyway, felt quick at the time. All right, so when we looked at F, we were like, okay, we need to measure out 2 pi over 3 radians, and then R was -3, so we wanted to measure out 3 units in the direction opposite the terminal side, okay? So we have our pole, whoops. We have our pole, we have our polar axis. That's where we kind of always start measuring out our angles. We measured out until we got to 2 pi over 3, which was here. So this was our terminal side, but R was negative. So we really had to measure out 3 units in the direction opposite our terminal side, which was right here. Okay, so we measured out 1, 2, 3, and we got a point right here. Okay, well, then we found that we had another point, another set of coordinates that put us at the exact same spot. That was kind of weird, right? So we had 3 comma -pi over 3. So let's do this one in blue. So we've got our polar axis. Okay, we want to measure out an angle that represents -pi over 3. Okay, and then we want to measure 1, 2, 3 units out along the terminal side. Since the R value is positive, we want to go along the terminal side, and we end up exactly where we left off. So this was the point F and the point G. Well, let's think about how we got there. Okay, so we have -3 comma 2 pi over 3, and then we had +3 comma -pi over 3. Well, we were able to reverse our R. So we went from an R of -3 to an R of +3. But what did we do to get from the angle in the first point F to the angle in the second point G? Okay. Well, if I take 2 pi over 3, I add or subtract something and I end up with -pi over 3. Well, how did that happen? Well, think about this. We basically created one big line right here, and we went from here all the way over to here. Let me do this in red so it's a little bit easier to see. So we ended up kind of like doing this thing. So we basically were along pi radians of each other. Okay. So essentially, what we ended up doing was we took that first angle, 2 pi over 3, and we subtracted pi radians. And when we did that, we got -pi over 3. Now, if you need to see it kind of worked out, we started out with 2 pi over 3. We subtracted pi radians. Now we want radians to be in fraction form with 3 as the denominator. We want pi to be in fraction form with 3 as the denominator. So that would just be 3 pi over 3, right? And then 2 pi over 3 minus 3 pi over 3 is -pi over 3. So if you have a situation where your R is negative, we can get the exact same point by making R positive and then either adding or subtracting pi radians to our angle measure. Okay, so essentially here we took whatever our angle theta was and we subtracted pi radians from it, and then we just made R positive and we get the exact same point. Now we can come up with infinitely many different ways to get this exact point right here We just have two of them. Okay, we know -3 comma 2 pi over 3 and 3 comma negative pi over 3. They represent the exact same location. Okay, so we need to kind of find ways that we can create new points based on previously existing coordinates. It's just kind of helpful to know there are going to be situations where maybe we don't want r to be negative, we want r to be positive, or we don't want our angle to be negative, whatever the case may be. So let's investigate. Okay, so we have this situation where like, okay, let's consider the point 4 comma 2 pi over 3. Okay, maybe I shouldn't have used 2 pi over 3. It's too similar to our previous point, but here we are. Okay, so what I have here is what is another way that we could represent the exact same point in the polar coordinate system? Well, up here we found that, hey, if we just make the r have the opposite sign and then add or subtract theta or add or subtract pi from theta, we end up at the same location. Okay, so we change the sign on r, and then we add or subtract pi from theta. So let's do that. So let's take r, which is 4, we're going to change it to -4. And then we're going to take 2 pi over 3, okay, and we're going to subtract pi. Well, when we do that, we get the ordered pair -4, comma, negative pi over 3. So let's go back up to our polar coordinate system and let's see if this works. So we're going to look at 4, comma, 2 pi over 3, and then -4, comma, negative pi over 3. So let's go back up here. Let's erase all this junk. I'm going to do it the quicker way this time so I don't, it felt like it was going to be really quick the last time to just like use the little eraser, but it took forever. All right, so we had 4, comma 2 pi over 3, and we want to verify that -4, comma negative pi over 3 is the same exact location. Okay, so we've got our pole, we've got our polar axis. Let's do the first point in red. So we're going to do this one in red. So from here, we want to measure out 2 pi over 3 radians. So that's going to put us right along this terminal side. Since r is positive, we're going to measure out 4 units on the actual terminal side. So that's going to be 1, 2, 3, 4. Okay. Now for the other point, let's do it in blue. Okay. So for this one, we have -4, comma, negative pi over 3. So from the polar axis, we're going to measure out pi over 3. Well, negative pi over 3. So that's going to be negative pi over 3 right here. Okay. So this is our terminal side. All right, but in this case, r is negative. So we don't want to measure out 4 units along the terminal side. We want to go opposite the terminal side. So we're going to go up 1, 2, 3, 4. We are at the exact same spot. So changing the sign of r and then adding or subtracting pi radians from theta puts us at the exact same spot. Okay, now one other way we could do it, instead of changing the sign on r, leave r alone, but just add or subtract a full 2 pi radians, okay? So if we change the sign on r, we're on this same like angle, like the same 100 degrees right here. So we're on this like same straight line. So to get from, let me do this in black, to get from like here down to here, we would just move pi radians, okay? So if we're not going to change the value of r, okay, if we're going to keep r the same, we would need to go around a full 2 pi radians in either direction, add or subtract. So down here, it says, can you think of a third way to represent this exact same point? So we started out with 4, comma 2 pi over 3. Well, let's leave 4 exactly the same, but then let's take 2 pi over 3 and add 2 pi. So one full like revolution, okay? So 2 pi, if I want to write 2 pi in fraction form with 3 as the denominator, that would be 6 pi over 3. So this is really 2 pi over 3 plus 6 pi over 3, which is 8 pi over 3, okay? So this would be the point 4, comma 8 pi over 3, okay? And let's see what happens when we get 8 pi over 3. So let's go back up to that rectangular polar coordinate system. Let's erase all the crap that I scribbled on it because it got real messy. Let's do this one. It was way quicker. Left a little bit down here. Okay, so let's keep the same point. We still have the 4 pi or 4 comma 2 pi over 3. So let's plot it again. So remember, you got your pole, you've got your polar axis. We want to sweep open to 2 pi over 3, which is right here. And we want to measure 1, 2, 3, 4. And let's do this one in red again. So this point, we're going to say right here. Okay, that is 4 comma 2 pi over 3. Now we decided, let's do this next one in blue again. We decided if we left 4 the same, but added 2 pi to our angle, that would leave 4 the same. We would add 2 whole pi radians to our angle. That gave us 8 pi over 3 radians. So let's measure, okay? So we start here at our polar axis, okay? We open and we know that if we're dealing with pi over 3, we have here, we get to 6 pi over 3. All right, this is going to be 7 pi over 3. This is going to be 8 pi over 3. This is our terminal side. All right, we want to measure 4 units from the pole to this terminal side, and bam, we end up at the exact same spot. Okay, so if you leave your R exactly alone, just go ahead and add 2 pi. Okay, or subtract 2 pi. You could subtract 2 pi as well. If you want to change R, if you want to change the sign of R, you only have to add or subtract just regular pi. Okay, so that's how you can get multiple points that represent the exact same location. And we have that laid out right here. Okay, so what we have here is you want to keep R the same, and then you add or subtract cycles of 2 pi radians, okay? So you can keep R exactly the same, and then you just add cycles of 2 pi or subtract cycles of 2 pi from your angle. Now, if you change the sign on R, it's a little bit different. If you change the sign on R, you start by adding just pi, okay? So change R, start by adding, or you could subtract pi, and then add or subtract cycles, I about spelled cycles with an S, cycles of 2 pi radians. Okay, so that's how you can find multiple points that represent the exact same location. I hope that makes sense. All right, so let's go ahead and look at example 2. So example 2 says, hey, represent the location of the following points in 2 additional ways. We got this, okay? So for the first one, let's keep 2 the same, okay? We're going to keep 2 the same, but I'm going to take pi over 4 and I'm going to add 2 pi. Okay? Well, when I do that, we have to think of how could we represent 2 pi as a fraction with 4 as the denominator. We would do 8 pi over 4. So this is going to be pi over 4 plus 8 pi over 4, which would make this point 2 comma 9 pi over 4. Okay, that would be our first point. That's one of infinitely many. You could, instead of adding 2 pi, you could subtract 2 pi. Instead of adding 2 pi, you could add 4 pi. You could add 6 pi. You could add 8 pi. You could subtract 12 pi. Okay, just as long as you're doing full cycles of 2 pi, adding or subtracting. Okay, now for our second point, just to be fun, let's switch the sign on R. Okay, so we're going to make R now negative 2. And if you change the sign on R, you first add or subtract just pi, and then you can add or subtract cycles of 2 pi. So we're going to take pi over 4. We're going to add just plain old pi, okay? So that's going to put us on that same like line, basically. So just pi radians, and then we can switch the sign on R, okay? So if we wanted to represent pi in fraction form with 4 as the denominator, we would just do 4 pi over 4. So we have pi over 4 plus 4 pi over 4, which makes this negative 2 comma 5 pi over 4. And if you have time, go ahead and try plotting those 2 points, okay? Actually, let's go ahead and just do it. So we've got 2 comma 9 pi over 4, and then we have negative 2 comma 5 pi over 4, and then we have 2 comma just pi over 4. So let's go back up to this big old mess. Let's clean it up. Erase all the junk that's already there. We've beat the heck out of this polar coordinate system, haven't we? Okay, so our original point was 2 comma pi over 4. And then we had 2 comma 9 pi over 4. And then we had negative 2 comma 5 pi over 4. So let's see if these all bring us to the exact same location. So let's start with the first point in blue. All right, so we want to open up an angle that is pi over 4 radians. So that's going to put us right here. Our R is positive, so we're going to go 1, 2 in the positive direction. Okay, so we've got that point right there. Okay, now for our next point, let's do red. So we'll do this one in red right here. Okay, so we have 9 pi over 4 and then positive 2, which is going to put us on the terminal side of 9 pi over 4. So if we go all the way around, that is 8 pi over 4. One more, doggone it, I hate when it does that little circle. So we've got 8 pi over 4, and then one more puts us right here. And then from the pole, we go 1, 2. We're at that same stinking point, okay? Which is fantastic, all right? Now, instead of keeping R positive, we decided to switch the sign on R, which means we just add or subtract just a single pi from our original theta. So we did that. So we need to, let's do this one in green. Okay, we need to measure out 5 pi over 4 radians. So 5 pi over 4 is down here. But this time my R is negative. So if this is my ordinary terminal side, the side opposite is over here. So I want to measure out 2 units from the pole in the direction opposite my terminal side. So 1, 2, I'll be doggone. We're at the same stinking point. Isn't that kind of fun? That's sort of fun. We've done this same point 3 different ways. We end up at the same exact spot. Okay, now let's do part B. And in part B, we won't play around. We'll just trust the system. Okay, so for part B, we have the point -2 comma 7 pi over 6. So for this one, let's keep the -2. And this time, just for fun, let's subtract 2 pi. So we're going to take 7 pi over 6 and we're going to subtract 2 pi. Now I need to write 2 pi as a fraction with 6 as the denominator. And in order to do that, I want 2 pi as a fraction with 6 as the denominator. So that's going to be 12 pi over 6. So we have 7 pi over 6 minus 12 pi over 6. Well, that's going to give me -5 pi over 6. So my new point is still -2 for R, and then -5 pi over 6. And my second point, let's change R. So remember, if you change R, you add or subtract just a single pi. Okay, so we're going to change R and make it positive. And then I'm going to take 7 pi over 6. And let's say we again just subtract a single pi. All right, so remember, if you change the sign on R, add or subtract a single pi first, and then you can add the cycles after that. So I need to find a way to represent pi as a fraction with 6 as the denominator, so we're going to do 6 pi over 6. So 7 pi over 6 minus 6 pi over 6 is just one single pi over 6. So my new point is 2 comma pi over 6. And I lied to you. At first, I was like, oh, let's not graph this one. Let's go ahead and see if we can plot this one just to make sure we're really, really, really good here. Okay? So let's get rid of all of this junk. This won't be too bad to just subtract, or to erase with my little eraser here. Maybe it's a little more involved. Okay, so the points that we want to look at. We have the original point. We'll do it in red. Whoops, was -2 comma 7 pi over 6. And then we'll do the next one in blue, which we said was going to be -2 comma -5 pi over 6. And then we'll do the last one in green, which we decided we're going to change R. So it's going to be +2 and then just pi over 6. So let's do the red one. Okay, so we first need to measure out 7 pi over 6. So where in the heck is 7 pi over 6? Well, let me erase a little bit more. I just saw I've got a little bit. All right, so here's my pole. Here's my polar axis. I want to measure out to 7 pi over 6, which is all the way over here. Okay, so this would be my terminal side, but R is negative. So I need to plot in the direction opposite, directly opposite my terminal side. So that would be here, and I want to go 2 units out, so I've got 1, 2, so we're right here. Okay, now let's try the blue point. So for the blue point, we want to measure out -5 pi over 6. So this would be like pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. This would be -5 pi over 6. Okay, so from the polar axis, we're going to go this direction. So that makes this my terminal side, but R is negative, so I want to plot 2 units from the pole in the direction opposite of my terminal side. So that's going to be over here. Isn't that something? All right, now let's do the last one in green. So we want to measure out pi over 6. So from the polar axis, that's right here, we're going to go pi over 6 radians. Okay, this is my terminal side. And my R is positive this time. So from the pole, I'm going to go 1, 2. I'll be daggone. It's that same stinking point. Isn't this fun? Okay, so please understand, as silly as I just was, please understand that there are infinitely many coordinates that represent the exact same location on the polar coordinate system, and you need to have at least a general familiarity with how to find additional points, okay? So that's it for this video. In the next video, we're going to learn how to convert between rectangular and polar coordinates. So we're going to learn how to convert between rectangular and polar, both directions, and then we're also going to look at rectangular equations, how to convert them to polar equations, and then how to take polar equations and convert those to rectangular. So we got a little bit of work to go, but I have faith in you all completely.